to the, if the everything ideal case, this will continue rolling no forever. But practically what happened? So let's assume that ground is like a tar road or like a RCC, and though it's iron sphere, what happened? It's not a perfect rigid body. Even though shot put is a very strong object made up of iron, still it's not a perfect rigid body. So when it is moving, it will undergo the displacement. It will undergo deformation. So it undergoes deformation. So the deformation will result like this. Where it will undergo deformation? It will undergo deformation at the bottom. And because of that, the normal contact will shift. Practically, this is what happens. And this is the center of mass. Let me save it. This is the center of mass C. This one, the normal contact will shift. This is the rough ground. Definitely, it should be rough, no? It should be a rough surface. The normal contact will shift. This is the weight. So this normal contact weapon will set up an anti-torque. Clear this? And what will happen to velocity of point P? The velocity of point P now will be non-zero. A slipping occurs. Because of slipping occurs, the friction will act backward. The net velocity of point P will be in the forward direction. So because this, what actually happens? This normal contact will set up a torque about center. Because of that, anti-torque is set up. And there it is having omega. Earlier it was omega naught, now it has become omega. Now the velocity of center was v naught, now it has become v. So first, what is the sequence? The body will undergo deformation. Because of that, normal contact will not pass through center of mass, will shift. This normal contact, what will do, will set up an anti-torque. Because of this anti-torque, the angular velocity of that decreases. Angular velocity decreases. Then the linear velocity will be more than the tangential velocity. So therefore, velocity of point will be towards right. So therefore, the friction will act backward. This friction, what will do, in turn will decrease center of mass velocity. You may say, sir, it will increase angular velocity. The resultant torque by the n will be more than f, because f is mu n, no? What is f? F is mu n here, slipping occurs. And what is n? So the value of f will be definitely less than n. So the net torque will be in this direction only. So it will undergo retardation. Finally, this rigid body will come to rest. This was the practically. You take any rigid body made up of any material. Ideal rigid body, it will not come to it because it will not undergo deformation. But what we have is a practical rigid body. This is what practical happens. Ideally, what I should say, it will continue pure rolling. But practical open, this is what happens here. Got the idea, no? So like this is what we have to give explanation. Means if you go to the ground, if you throw a shot put, what do you expect? You introduce with pure rolling. Then what do we expect? It must reach from one end to other end, but such a thing doesn't happen. The reason for that is the deformation. The shot put also will undergo slight deformation. Because of that, we'll get a situation here. And finally, it comes to rest. This is during motion. So definitely your work done by friction, normal contact will be non-zero. Fine. So now let's get into the toppling idea. Still some good problems are there. Tomorrow after paper discussion we'll discuss. Huh? Still some very good ideas are there. Because it's an unlimited topic. We can never finish off this topic. For namesake, for exam sake, we have covered some ideas. But we can keep on discuss this for another 1 month if you want. Rolling motion. Okay, let's get into the toppling concept. Top